So system is basically connection of some components or subsystems that operates on input signal, which are generally denoted by X, and gives you an output signal. So what we are saying is that xt is getting converted to yt. Xt signal is getting converted to yt when it is operated by some system S. Okay, या इसको ऐसे भी देख सकते हैं. In a S system, there is some transformation which can be made, which will operate on xt to give you the output yt. In the system S, yt, the output will be obtained by input using some kind of a transformation called t. T is some operator which operates on the input and gives you the output. So what are the systems? To get you some physical examples, let us suppose we have a situation, because we are electronic people and you know what is resistance, what is capacitance. So suppose these are the components, they are connected together, resistance and capacitance, and when you input and signal, you will get some capacitor voltage as output. So this thing which converts input to output is called system. This thing which is applied here, it is called input signal, and this thing what you measure from the system is called output signal. So this thing, connection of components which operates on input and gives you the output signal. Okay. For example, there can be many other examples, like suppose we have a car, moving car. There is a moving car which is responding to applied force F from the engine to the retarding force proportional to the automobile velocity. Okay? So this is also an example of system where the input signal is force and the output signal is velocity. Output signal is velocity of the car. Okay, input is force which is applied, and v is the velocity which it gets. Okay, v is the velocity. Generally there can be many input, many output systems, but we will be concentrating on single input, single output system. Okay, single input, single output system. Okay. Now there could be a way in which outputs can be expressed in terms of inputs. For example, in this system, what will be the IT? The current in the circuit. Current in the circuit will be something like this: V input current, input voltage, minus the output voltage, input voltage minus output voltage divided by R. Okay, divided by R. This is the रेजिस्टेंस के अंदर करंट जो है वो ये होगा. कैपेसिटर के अंदर करंट क्या होगा? कैपेसिटर के अंदर, और दोनों इक्वल होंगे. कैपेसिटर के अंदर करंट होगा C इंटू dV बाय dt V आउटपुट. ठीक है, V आउटपुट. दिस विल बी कैपेसिटर वोल्टेज. Okay, so when we rearrange this equation, what do we get? we will get a something like this: d by dt v output plus 1 by RC v output equal to 1 by RC v input. Okay, so this kind of equation can be obtained for this system where the output, अगर हम आउटपुट को हम yt कहते हैं, आउटपुट सिग्नल को yt कहते हैं, so dy by dt plus 1 by RC yt is equal to 1 by RC xt. So output signal can be expressed as differential. This is called differential equation. So differential equation can be used to express the relationship between input and output. Okay, input and output. Okay, so this is one example where we can express our input and output signal mathematically. Okay, so this is example of continuous time signal. There could be situations where discrete time signals could be there. For example, if we can define a system of a balance in an account, बैंक अकाउंट में जो बैलेंस है उसको हम सिस्टम अगर डिफाइन कर लिया तो what we can say is that if yn is the balance at the end of nth month, nth मंथ में क्या बैलेंस है, ठीक है, और इसमें जो xn है, xn इज नेट डिपॉजिट. आपने नेट डिपॉजिट क्या किया ड्यूरिंग द मंथ, आपने नेट डिपॉजिट ड्यूरिंग द मंथ क्या किया, ठीक है. And let us suppose the system is defined by 1% rate of interest. Okay. Now this system can therefore be represented by writing yn. Yn means balance at the end of nth month will be equal to जो आपका पिछले महीने का बैलेंस था. पिछले महीने का बैलेंस क्या था, yn-1. दिस विल बी द बैलेंस ऑफ द मंथ अर्लियर मंथ. पिछले मंथ में आपका जो बैलेंस था उसको हम yn-1 कह सकते हैं. ये nth मंथ में और ये n-1 मंथ में, यानी पिछले मंथ में. पिछला महीना हो गया ना x माइनस n. ओके, अगर n ये वाला करंट महीना है तो n-1 पिछला महीना हो गया. तो इसमें हमको कितना इंटरेस्ट मिल रहा है, 1.1% मिल रहा है. तो ये तो उसमें ऐड हो जाएगा इंटरेस्ट, पिछले मंथ का इंटरेस्ट प्लस नेट डिपॉजिट. जो नेट डिपॉजिट आपका इस मंथ में है xn. ओके, xn इस मंथ का नेट डिपॉजिट जो है. सो टोटल बैलेंस एट द एंड ऑफ nth मंथ विल बी दिस yn और नेट डिपॉजिट इस मंथ में xn and y of n-1. This will be your system which will be defining the balance at the end of nth month. Okay, balance at the end of nth month. Okay, so this is the example where discrete time systems could be there. This is the example of discrete time system. Okay, getting my point? First year. So there can be two situations where the system can be represented by continuous time domain, or it could be represented by discrete time domain system. Okay, अगर ये discrete time signals को deal करता है तो discrete time system, और continuous time system को deal करता है तो continuous time system. There can be situations where both the systems can be intermingled, मतलब दोनों signals भी system में मौजूद हों, but that situation is beyond the scope of our discussion. हम ऐसे systems को नहीं पढ़ रहे हैं इस बार इस syllabus में. We will be restricting ourselves to either the continuous time systems or the discrete time systems. ओके या तो हम कंटिन्यूस टाइम सिस्टम्स के डोमेन में रहेंगे या फिर डिस्क्रीट टाइम डोमेन में. दोनों को कंबाइन कभी नहीं करेंगे. वी विल बी स्टडिंग एक्सक्लूसिवली कंटिन्यूस टाइम सिस्टम्स एंड डिस्क्रीट टाइम सिस्टम्स. ओके, बट देयर आर सिचुएशंस वेयर बोथ ऑफ देम कैन बी क्लब टुगेदर टू सॉल्व सम सर्टेन प्रॉब्लम्स, एंड दैट इज बियॉन्ड द स्कोप ऑफ आवर डिस्कशन. ओके.